In this lesson, you'll learn what it takes to even make a triangle out of the three sides. We can't just assume that all three lengths, any three lengths, would make a triangle. There are certain situations that have to happen. And then the other thing that you'll learn today is the relationship between the angles and the sides and how things are placed within the triangles. So if you go through this activity using either Snapsticks or you go into GeoGebra, you'll find that there are certain requirements that have to be met in order for three side lengths to make a triangle. So if we found that maybe these three different measurements, these three different groups of lengths did make triangles. And then we have these other three here where they didn't. So these did, and then the ones in the bottom table did not make a triangle. So let's look at what they have in common then. If you look at the ones that will make a triangle, I put them in order from least to greatest. Notice that the sum of the two short ones, 2 plus 3, is bigger than 4. 3 plus 3 is bigger than 5. 4 plus 7 is bigger than 10. And so what happens is if we have a length of 2 and a length of 3 and a length of 4, then those three lengths, imagine if you had a board that was a length of 4 and then you nailed a 2-foot board and a 3-foot board on either end and you hinged them in, then when you fold those in, these two boards here are going to hit each other and they're going to form a triangle. Whereas, if you look at these other ones, 3, 5, and 12, say I take that longest board, that's 12, and I nail a 3-foot board down here and a 5-foot board down here, then when I swing those boards down, that's only 8 foot worth of board, and so it's going to leave me with 4 feet worth of space that's not going to make a triangle. Those two boards are not going to hinge down and hit each other. The same thing. So 3 plus 5 is less than 12. 2 plus 2 is less than 7. And this special case, 3 plus 4 is equal to 7, because what happens there is if I have a 7-foot board, and say I take a 3-foot board and a 4-foot board, and then I close them down, what's going to happen is I've got that 7-foot board, and then my 3-foot board and my 4-foot board are going to close down all nice and snug and be the exact same length. So they're not going to form a triangle. So what has to happen is that the sum of the two short lengths have to be greater than the third side. So that's what it takes to be a triangle, is that the sum of the two short sides, sorry about that, has to be greater than the third length. So let's decide whether the following lengths form a triangle. Now be careful, don't get in the habit of thinking that it's always going to be the first two have to be bigger than the third. It has to be the two short sides. Okay, so 4 and 7 and 11. Since 4 and 7 are the smallest, we want to test it. Is 4 plus 7 greater than 11? The answer is no, it's equal to 11. It has to be greater than, not equal to, just greater than. You might make a note over there, not greater than or equal to. Okay, so then let's test this one. Now notice this one's not written in order, so we need our two short sides. So 2 plus 5. 2 plus 5 has to be bigger than 9. So 2 plus 5 is 7, which is not bigger than 9, so these will not form a triangle. So let's look at this next one. 10 plus 14, is that bigger than 15? 24 is bigger than 15, so the answer is yes. These three lengths will form a triangle. And then 6 and 8 are my short lengths, so 6 plus 8, is that bigger than 10? 14 is bigger than 10, so yes, it does form a triangle. Now, to determine, so what if I give you two lengths and I want to know then what are all the possibilities of measurements that I could use? So if I have 5 and 9, so what you're going to do is you have to consider, okay, what if 5 and 9 are your two short sides? Well, then they have to be bigger than the sum of them. So 5 plus 9 is 14. So the third side would have to be bigger than 14. Now, what if it's not? What if the other side is not the longest side? Well, if you take those and subtract them, 9 minus 5 is 4. So what that tells you then is anywhere between 4 and 14 would work. So let's just do a quick test. What if it was 4, 5, and 9? Well, that wouldn't work. So, but that's going to tell us something about how we write this inequality. How about 5, 5, and 9? So this is the number that I'm changing right now. I'm kind of guessing. If all else fails, you can just start picking numbers and guess. Well, that one works. So you could have 5, 5, and 9. What about 6, 5, and 9? Well, that would work. 11's bigger than 9. 7, 5, and 9. Well, that's 12, which is bigger than 9. 8, 5, and 9. That's 13. 9, 5, and 9. That's 14. So that works. 9 and 5 is 14, which is bigger than 9. 10, 5, and 9. Okay, so now you've got to switch, right? Because now these two, your 5 and 9, are your smallest ones. So those are 14, bigger than 10. That works. 11, 5, and 9 works. 12, 5, and 9 works. 13, 5, and 9 works. 14, 5, and 9 does not work anymore, because 5 plus 9 is 14, and 14 equals 14. So you can do that, but you don't want to do that for every problem. So the easiest thing to do is add the numbers together, and that's going to be your big side. Subtract the numbers from each other, and that's going to be your small side. And so then here's how you write the inequality. So my numbers, my lengths of my boards, if you will, have to range from 4 to 14. And my numbers need to be in the middle. So if you will always do it like this, then it will always work the same way. You put your lower number on the left-hand side, your bigger number on the right-hand side, and then you can always use less thans. Not or equal tos. Because remember, when it was equal to, it didn't work. My 4 and my 14 didn't work when I plugged them in. And I did what I know about the sum of the two short has to be longer than the third. Okay, and so then that's your interval. So the length of board that I would have to buy would have to be between 4 feet and 14 feet. Any shorter or any longer would not create a triangle. So if we look at this one, if we add 10 plus 6, that gives me 16. That's going to be my high side. If I subtract 10 minus 6, that gives me 4. That's going to give me my low side. And then all of my boards have to be in the middle, between 4 and 14. Bigger than 4, but smaller than 16. Okay, and so you always use less thans, not or equal tos. Don't forget, no or equal tos. Okay, no or equal tos, just less thans. So that's the sum, that's called the triangle inequality theorem, and that's how you can determine what 3 side lengths make a triangle. So now let's look at some relationships in these triangles. So I have 3 triangles here. And what we want to do is just kind of look. What do you notice about the location of the shortest side relative to the smallest angle? So here is my smallest angle. And if I look, here is my shortest side. Notice that it is across. Then let me show you this. Okay, now in this case, these two are equal to each other. Well, it's interesting though, because if you notice, the sides that are across from those are also equal. So when the angles are equal, the sides that are across from them are equal. And then we have the smallest side is across from the smallest angle. Let's look and see if that's always true. My smallest angle is right here at 24, and the side that's across from it, that's not forming the angle, is 6. Let's look at this medium angle. Here's my medium angle, 59 degrees. And then my medium length side is 13. It's in between 6 and 15. I notice those are across from each other. And then I have this big angle, this obtuse angle, 97 degrees. And the longest side is 15. So notice that in every single one of these cases, the side and the angle matched each other that went together. So basically then what we notice is that our short side is across from, or opposite, the smallest angle. And then what we also noticed then, remember your medium side was across from your medium angle and your large side was across from your long angle or your large angle. And so then we know that our long side is opposite or across from the largest angle. And that makes sense because the angle has to open up wide. You have to draw a longer line to attach the ends of them. So it says order the angles in each triangle from smallest to largest. So in order to find the smallest angle, we need the shortest side. So my shortest side is 9, which means that angle Q has to be my smallest angle. And then after that, I have my medium length, which is 14, which goes with S. So S has to be then my medium length. And then my longest side is 15, which is across from R or formed by R. And so angle R then has to be the biggest. So what if we don't have a triangle? That's okay, we can draw one. So let's just draw one. It can be any triangle, it doesn't matter. Y, X, W. I always think it's easier to look at it with a triangle than it is to look at all these letters. It gets confusing with all the letters, so it's easier if you just draw a picture. Just draw any random triangle, and then let's label it. XW is 8, YW is 10, and YX is 15. Okay, so now it's easy to see which angle is the smallest angle because the smallest angle has to be across from the shortest side. So the shortest side is 8, and so Y has to be the opposite. Now notice, X and W touch, right? There are the end points of that shortest side. So you have to use the third angle, that third vertex. So angle Y then is my smallest angle. And if you need to, find your biggest angle next. 15 is your biggest side. So that means, and it has endpoints of X and Y, so that means W then has to be your longest. Sometimes it's easier to find your short and your long and then pick the one that's left in the middle, which means that angle X has to be in the middle. So we can tell that the smallest angle is across from the shortest side and the largest angle is across from the longest side. So now let's work that from a different direction. Order the sides of each triangle from the shortest to the longest. So in order to determine which one is the shortest side, we need to find the smallest angle. So the smallest angle of the three is this 30 degrees, and the ends of that 30-degree angle are at W and V. They extend out and they hit at W and V, which means that WV is my smallest or my shortest length. Then my next angle is this 70-degree angle. It is across from WX, so WX is my medium length. And then VX is my longest side because it's across from this 80-degree angle. And so it would be VX or XV, either one. Now, you might be missing those little angle symbols, but that's what should be there. Look at number 6. In triangle DEF, D is 32 and E is 74. Well, it's hard for me to determine the side lengths and which one is the shortest and the longest when I don't have all three angles. That's okay. We know how to find them. So we've got D, E, F. D, E, and F. I know that D is 32, so I can label that. That's 32. E is 74, and we know if we reach way back into what we have learned before, we know that triangles add up to 180. So 180 minus 74 minus 32, or you can add them up and subtract from 180. You find out that angle F is also 74. So in this case, notice if I have two angles the same, that means I'm going to have two sides are the same. So my shortest side is across from my smallest angle. Well, here's my 32-degree angle. So that means then that my shortest side has to be EF. And then my other two sides, ED and DF, they're going to be the same length, because then this triangle has to be an isosceles triangle. It has two side lengths that are the same. It makes sense if the two angles are the same length, then the sides that are across from them would have to be the same length also. So now what we know from that is that the short side is across from the small angle and the long side is across from the largest angle. You can imagine that you have that angle opened up. So you're going to have from end to end, you're going